Hello, this is Rick Guptill, and this is RoboSim Pro. We're going to make a demo today of how to install a robot in a customer part that requires sealing. And we're going to create the path in the program, the PDL program, to actually make it work. So here we installed the robot, and we have this, which is actually a gun, is actually a hypertherm torch, but we're going to call it a sealing gun. And what we can do is we can import a lot of different CAD formats, including DWG. And in this case, the part that we're going to seal is a 2D DWG file. And you'll see here that it has curves that we want to simulate. So we're going to say that we want to seal this curve right here, this yellow curve inside these two green curves. So if we look at this carefully, these particular curves, this curve is actually many curves put together. I think maybe it's 20 curves or so. And they're different lengths, and they're actually not in the order. And so what we want to do is we want to convert all these into one curve that we can use. So we have a function in here in our CAD to path for curves that's called join curves. And what we can do is we can zoom in here, and the left mouse will click this curve, this yellow curve. And this is the actual curve piece, number 15. This is the parent that you see in the quick pick over here, and this is a child, and this is the parent of all these curves right here. Okay, I'm going to call it seal 1. So this just joined all of those. You can't really see it here, but it's right underneath the yellow guys. Okay. So what we can do is we can pick we can either hide the other curves that we just created, which if it doesn't hide, it means we're hiding the, okay, there we go. See that we had the yellow curve. This gray curve is the joined curve that we have. So what we can do is in this CAD to path application, we can drop frames on this curve. So I'm going to select this gray curve, which is seal 1. And there's different options that we can use here to drop what we call frames on there. In this case, constant distance means every 10 millimeters. This is in units. The units are in 10 millimeters. We can drop frames, and let me set this. These size of these frames are big, so I'm going to set them to be smaller. This really depends on the application you're using. You can see that every millimeter, every 10 millimeters, we create a frame. You can also put a total number of frames, or what we're going to do today, you can set a tolerance that you want. So we're going to say 0.1 millimeters. And you can see that along tight radiuses, there's a lot of frames. And then you'll see as soon as the screen comes back that along straight sections, there's only a start frame and an end frame, so it matches the tolerance. So here there's a straight position, straight, straight, straight. So you only need a frame at the start and the end. It's a straight line. Okay, one more thing we're going to do before we use this is we're going to see how the x-axis follows the curve tangent. Some of that applications is good to have that, but what we're going to do is we're going to move the teacher to this edge, and we're going to notice that the x of the teacher points out this way. So we don't want our tool to be rotating all the time. We think it's just going to seal, just going to keep the x the same. So I'm going to keep the x the same. Still going to do tolerance mode, but then the z will point up, and then we can use these frames to actually move the robot. Okay, now it's a good thing to do to be able to create a path for the gun just using the frames we just created. So what we could do is either pick on individual frames, like I want this one, and this one, and this one, or I'm going to cut those. We can just use the left mouse, hold it down on the frames, hit the parent, and then it takes all the frames that are under there. Okay, so let me slow the simulation down a little bit, and I can go to the test path, and I can actually run this guy. Okay, so it can't reach any of it, so what we're going to do is we're going to move the part that we just created. We're going to drag it over here and put it in front of the robot. So it's probably at a good place for the robot. And then we'll try test path again. And what we can do is we can kind of see that how it's going to move. You can kind of see right here it goes through a singularity. It's kind of not in a very good place. So I'm going to move it to one side. And it's going to move that joint 5 away. And it's probably going to be okay. Yeah, that's pretty good. Joint 5's there. Okay, so then next what we're going to do is we're going to edit the via attributes of this path and then create a program. All right, thanks.